Good morning, students. Now we are going to discuss about unit 3 concepts. So in part of unit 3 we are going to discuss about Bayesian learning and computational learning and instance-based learning. So these are the topics we are going to discuss in the unit 3. So Bayesian learning, computational learning, instant-based learning. So these three topics we are going to discuss in the part of unit 3. So initially I am going to start the discussion with Bayesian learning, and so it is also known as Bayes' theorem. Okay, so in order to discuss about Bayesian learning, so what you have to see, that is BNN, Bayesian neural network. So here we are going to see the Bayesian neural network. So using the Bayesian neural network we are going to discuss about Bayesian learning methods. Okay, so Bayesian learning methods. So here in the part of Bayesian learning methods we discuss about Bayes' theorem. So what the Bayes' theorem, already you people have some knowledge over Bayes' theorem, I think so. So in Bayesian learning we are going to use the Bayes' theorem. So here we are going to use some hypothesis. Hypothesis is an assumption or a statement which we are going to be predict. So using the Bayes' theorem we are going to calculate the hypothesis, and so in order to revise the probability of an event we are going to use the Bayes' theorem. So it is going to calculate the conditional probability. So it is also called posterior probability or revised probability. So what we can call posterior probability or revised probability. So that we are going to calculate. So here what we are going to see, so it is a theorem which is based on conditional probabilities. Suppose if A and B, so both are going to represent two events, let us assume, then what we are going to calculate P of A by B. So it is going to denote the conditional probability. What it is going to denote? Conditional probability. So what it tells, so it is A occurring given that B occurs. So A is going to be occur, so whenever B is occurred. So by assuming B occurred, then what we are going to feel, so A is occurred. So we are using the A and B events, what we are going to have two conditional probabilities. One is P of A by B, P A given B, and P of B by A. So probability of B by given A. So it is going to tell about the relation between P of A by B and P of B by A. Okay, so using Bayes' theorem what we are going to find out, so posterior probability we are going to find out, so that is P of A and P of B. So here what we are going to calculate, so posterior probability, so it is a probability that has been revised by using additional information that is later obtained. So if A and B are two random variables, then P of A by B, if A and B are two random variables, then P of A by B equals to P of B by A into P of A by P of B. So this is the Bayes' theorem. So this we are going to prove with the help of Bayes' theorem. P of A by B equals to P of B by A into P of A by P of B. So if you look at carefully, so what you have written just now, P of A by B. So what is this P of A by B? Posterior probability. Okay, so equals to what you have written, P of B by A, P of A B by A. So what is this? Likelihood probability, likelihood probability, likelihood probability into P of A. So this P of A is prior probability, prior probability by P of B. So this is marginal probability, marginal probability. So what you are going to calculate, that is posterior probability. What you are going to consider another conditional probability, that is likelihood probability, and P of A is prior probability, P of B is marginal probability. So these are the terms which we are going to be used in Bayes theorem. So initially, so if A and B are two events, how can we calculate P of A by B? So that means P of A intersection B by P of B. So P of A by B. So probability of A given B. So that conditional probability we are going to calculate with the help of P of A intersection B by P of B. In the same way, P of B by A equals to, again, P of B intersection A by P of A. Right? So here P of A intersection B equals to P of A intersection B equals to, so if you are going to take this formula, so P of A intersection B equals to P of A by B, is it or not? P of A by B into P of B, P of A by B into P of B. So here also one more is there, P of B intersection A equals to P of B by A into P of A. So that what you can write, A of A intersection B equals to B intersection A. So that what you are going to write, P of B by A into P of A. This is also same, right? And then P of A by B equals to, so this we are going to replace in this formula, above formula. So this value we are going to substitute in here, P of A intersection B. So what is going to be P of B by A into P of A by P of B. So this is the way we have proved the Bayes theorem. Okay, initially P of A by B equal P intersection A by B, P intersection B by P of B, and then P of B by A in the same manner, P of B intersection A by P of A, P of A intersection B equal P of A by B into P of B. It is also equals P of B by A into P of A. So now this value is going to be substituted with the help of P of A intersection B, so that we got this value. So this is the formula for Bayes theorem. Okay, so if you look at one simple example, so P probability of king face, the probability of king face. So what you are going to, if you take cards, there are 52 cards, right? So among the 52 cards, so some are face cards. What are the face cards? King, queen and joker, so jockey. With these three cards are face cards. So we can see face with those cards. And each card consists of four number. So total how many face cards we can have? So in a deck we are going to have 52 cards. Among 52 cards, 3 cards are face cards. And 3 into each card, 4 different types. Yes or no? So that is 12 cards. Total 12 face cards are there. So among the 12 face cards, suppose I am going to pick one card from 52 cards. So it should be king. It should be king. The probability of king. So whenever I am going to pick one card from the 52 cards, so it should be king. So in order to king, so what it should be? First it should be face card. Then among the face card and it should be king. So in order to find out this, what is the formula? P of face by king. The face card must be king, and P of king and P of face. As per the Bayes theorem, this is the formula we are going to write. And the king and it's a face card. So what is the probability? That probability is 100%, that is 1. And P of king. So P of king in the sense, total 52 cards. Among how many kings are there? 4 kings. So what is the probability of P of king? 4 by 52. And what is the probability of face card? there are total 52 cards are there, among 12 face cards are there. So 12 by 52 is the probability of P of face. Then what is the value? So 1 by 3 is the result. So this is the, whenever you are going to pick a card, so it should be a face card and it should be king. So what is that probability? The probability of occurrence is 1 by 3. Like this we are going to use the Bayes theorem for finding the probability of particular entities by assuming conditional probabilities. In the same way, if you look at one more example, see here one example is given. So what this example it is showing, read out. At a certain university, 4% men are over 6 feet tall and 1% women are over 6 feet tall. The total student population is divided in the ratio 3:2 in favor of women. If a student selected at random from among all those over 6 feet tall, what is the probability that the student is a woman? So as per the given data, let us assume that M is the student is male and F is student is female, and T is for student is over 6 feet tall. So these are the assumptions we are going to consider. M is for male, F is for female, and T is for 6 feet tall. So what is the given data? See there. So the total student population is divided in the ratio of 3:2 అన్నాడు. 3:2 in favor of women. That means 3 is the woman, 2 is the men. Total 5. So what is the probability of P of male? 2 by 5. 2 by 5. And what is the probability of female? 3 by 5. So what is the P of T by M? So here one more it is given, 4% men are over 6 feet tall. 4% men, 4%, and the 400 lo 4. So P of T by M equal to tall men is 4%, so that 4 by 100. So what you have to find out? You have to find out what is the F by T. So F by T in the sense I have selected a student. So that student should be taller and the particular student must be woman. So that you have to find out. What you have to find out? P of F by T we need to find out. So using Bayes theorem, P of F by T equals to P of T by F into P of F by P of T actually. So that P of T is going to consist of, here P of T going to consist of tall persons, right? So in order to get the P of T, what you are going to write? P of T by F into P of F plus both the cases we are going to consider, taller female and taller male. P of T by M into P of M. So this is the expansion for this P of T. So that's why here I have written like this, and just substitute the values, then we are going to get the probability of F by T is 3 by 11. 3 by 11. Clear? Like this we are going to solve the problems. Thank you. This is about Bayes theorem.